Hello math friends, this is Precalculus section 2.5 day 1 notes. We're going to be talking about quadratic functions. And you'll remember from Algebra 2 that quadratic functions are functions that look like y or f of x. We like to use f of x in Precalculus. F of x equals ax squared plus bx plus c. Now in Algebra 2, we call that standard form of the function, but your textbook refers to standard form as the vertex form of the function. That's what we're used to calling it from Algebra 2. So vertex form of the function looks like this. F of x equals, we've got our same a value, but then it's in factored form, x minus h squared plus k, where hk is our vertex, and we can see it right in the equation. So obviously for graphing, that's very handy. And again, I just want to put here that we're used to calling this vertex form, and I will still call it vertex form. So if a is greater than 0, meaning positive, then our parabola is going to open up. If a is less than 0 or negative, then our parabola is going to open down. So for our first example today, we have an equation, and it says to write this equation in standard form, which again means that we want to write it in vertex form. And then we want to sketch a graph of it. And after we make our graph and do our work here, we want to state the maximum or the minimum value of the function. So if we've got f of x equals x squared minus 8x plus 13, our job is going to be to restructure this equation so that it looks like a times the quantity x minus h squared plus k. So in order to change something into that form, we are going to have to use completing the square. So I am going to start by just writing out my function down here. F of x equals x squared minus 8x plus 13. And I'm going to start by figuring out what is the term that I would need to add to complete the square. Now this is a great problem to do this because remember, to complete the square, our a value in front of the x squared needs to be a 1, and it is in this case, so we don't have to do any dividing. That can get a little bit messy when we do. So we can go ahead and we can add our box to both sides of the equation. So on the right side, we're going to have x squared minus 8x. I'm going to go ahead and add my box. I'm not going to subtract that 13 over. I'm just going to leave it there, okay? And on the other side of the equal sign, of course, I also have to add that box because the rule is what you do to one side, you must do to the other. Now to figure out what goes in the box, I take my b term, which is that negative 8 in front of the x, I divide it by 2 and I square it. So negative 8 divided by 2 is negative 4. Negative 4 squared is positive 16. So 16 is what is going to go in my box on both sides of the equal sign. Now this x squared minus 8x plus 16, that's my perfect square. That is going to factor into x minus 4 quantity squared. And then after I do that, the last step is just going to be to get f of x alone. So I'm going to subtract that 16 over to the other side, and that's going to leave me with f of x equals x minus 4 quantity squared, and then positive 13 plus negative 16 leaves me with negative 3. So now my equation is in vertex form. I can clearly see the vertex in the equation. My vertex, now remember, the value of h is always opposite of what you see, and the value of k is always the same as what you see. So the value of h here is going to be positive 4, and the value of k is going to be negative 3. And I should also note, for graphing purposes, that my a value, the number in front of the parentheses, is 1. So now we're ready to sketch a graph. So I'm going to start by plotting my vertex. My vertex is going to be at positive 4, negative 3. So here's my x-axis right here. I'm just going to darken that a bit. and there's my y-axis. So my vertex would be at +4, -3, which is right there. Now, the fact that I am paying attention to a being 1 tells me that this graph is going to be the same width as the parent graph, y equals x squared. So I can just envision what the graph of y equals x squared looks like. If I plug in 1 and I square it, I get 1. So I'm going to go, pretending that this vertex that I just plotted is kind of like my new 0, 0. I'm just going to draw what the parent graph y equals x squared looks like with this new vertex. So I would have this point 1, 1, I would have the point 2, 4, and I would have the point 3, 9. And then, of course, I would just reflect these points over my axis of symmetry to make the left-hand side of my graph. So there's the graph of this function f of x. And then the question is, does the graph have a maximum value or a minimum value? This value is occurring at the vertex right here. And since it's at the bottom of the parabola and the parabola opens up, this is a minimum value. And our minimum occurs at the point f of 4 equals -3. Maximum or minimum values of quadratic functions always happen at the vertex of the parabola. The maximum or minimum value is the y value, because that's the height. So it's the y value of the vertex. Another way to find the vertex of a parabola is to find the x-coordinate of the vertex using the formula the opposite of b divided by 2 times a. And I'm sure you remember that from Algebra 2 as well. And then if you solve for the x-coordinate using that formula, you would find the y-coordinate by plugging the x-coordinate into the equation to find the corresponding y value. So let's practice that method on example 2. We're going to find the vertex of f of x equals -2x squared plus 4x minus 5. And then once we find our vertex, we can write the equation in standard form and figure out the maximum or the minimum value of our equation. In this equation f of x, our a value is -2, our b value is +4, and our c value is -5. So if we're going to find our x-coordinate by taking the opposite of b over 2 times a, for this equation, that's going to be the opposite of 4 over 2 times -2. So this is going to become -4 over -4, which gives us an x-coordinate of +1. Then to find our y-coordinate, we are simply going to plug that into the equation. So our y-coordinate is going to be equal to -2 times 1 squared plus 4 times 1 minus 5. And if we do the math on that, 1 squared is 1 times -2 is -2, 4 times 1 is 4, plus -5. -2 plus 4 is 2, and then 2 minus 5 gives us a value of -3. So we just found our vertex. Our vertex is the point 1, -3. Now we know for this equation that our a value is -2. Okay, that tells us, because our a value is negative, that our parabola is going to open down. And since our parabola opens down, this vertex for this parabola is going to be a maximum value. Okay, And that's because our a value is -2 and it opens down. Okay. So over here by my sketch, I'm going to say that this opens down because our a value is -2. Okay. And if our vertex is at +1, -3, this doesn't lend very well to my graph here. My parabola is going to look something like that. All right, so standard form, remember our standard form, I'm going to write it in their line here, is f of x equals a times the quantity x minus h squared plus k. So for this particular equation, we know our h, we know our k, and we know our a, so we just have to plug them all in. So the standard form of our equation is going to be f of x equals -2 times the quantity x minus 1 squared minus 3. So I just want to review for a moment that we just talked about two ways that we can find vertex form of an equation. One way, which we used in example 1, was by completing the square. The second way was for finding the vertex using the formula opposite of b over 2 times a, and then plugging that x value in to find y. When we did it with example 1, our a value was 1, so completing the square was the way to go for that problem. But for our second example, a was not 1, and so I chose to find my x coordinate using opposite of b over 2 times a. You could use either method in both cases, but it is harder to complete the square when a is not 1. So that's just something to think about as you work through these problems. For our last example, we want to express this equation in standard form, find the vertex, x-intercepts, and y-intercepts, and sketch the graph. And it says here, note, you can use either method to find standard form. Since a is 1, I'm going to use completing the square, and I just want to note here that my c value is a 0. Okay, so if I'm going to complete the square, then I'm going to have f of x equals x squared plus 4x. I'm going to go ahead and add my box to both sides of the equation. To figure out what goes in the box, I'm going to take 4 divided by 2, which is 2, and then square it, which again gives me 4. And my c value over here was a 0. So now I'm going to factor this side, and this factors into x plus 2 quantity squared. So now the last step is I just need to get f of x alone. So I'm going to subtract that 4 from both sides. So my equation is going to be f of x equals x plus 2 squared minus 4. I definitely think when a is 1, this method is faster. So this is what your book would call standard and what I would call vertex form. So now we know that the vertex of our parabola is going to be at, remember h is opposite of what you see, so -2, -4. Once again, I need to darken up my x-axis a little bit. So if I go to my vertex, -2, -4, and again, my a value is 1, so I can just duplicate that y equals x squared parabola with this vertex. So I'm going to go over 1, up 1, over 2, up 4, and over 3, up 1, 2, 3, 4, 5, 6, 8, 9. And then I can just reflect these points over to build the left side of my parabola. Okay. I can see from my picture that my x-intercepts are at -4 and 0, and that my y-intercept is at 0 because I've got that point 0, 0 on my parabola. Now remember, if you don't have those on your picture, you could also find your x-intercept by plugging in x equals 0, solving for y, or sorry, find your y-intercept by plugging x equals 0 in and solving for y, or find your x-intercept by plugging in y equals 0 and solving for x, and that gives you another way to solve for those intercepts.